in this question and this one here, we've been asked about some domains. So here we're saying state the domain of the graph where y equals 4 plus this is greater than 1. And then for this one, we're looking for an implied domain. So with this one, let's see if we can just solve it with CAS. So on CAS, it's going to say solve. We're going to write this down. 4 plus, that's a negative 1, so I'll turn it to a minus 1 divided by, open brackets, x minus 1 all squared, x minus 1 all squared, and we're looking for where is that, greater than or equal to 1. So that thing greater than or equal to 1, and we're solving that for x. Let's see what it does. Oh, that's terrible. 3 on 3. 4 plus that. That's none of the options we've got there. Okay, so let's check to make sure we've entered it incorrectly. It looks okay. The only thing that's different is this plus. So let's go up. Let's change this to a plus and make that a negative 1. Let's do the same thing. This is a worry. It's really frustrating. Maybe this was a mistake. Anyhow, let's try it again. Define. Let's define this thing. 4 plus f of x equals 4 plus negative 1 divided by x minus 1 minus 1 squared minus 1 squared. Okay, so that's what we've got there. 4 plus x minus 1 squared, 4 plus x minus 1 squared. Solve. Where is that thing? F of x. Where is that greater than 1? Let's just have a look at that, just save a bit of time. We're solving for x. Okay, we've got the same thing. Alright, so what we'll do, we'll graph that. Let's see what we can do here. F of x. So we've got there. Now we're going to graph 1 as well. So then we're going to look for some intersection points. So it looks as though CAS will be saying where x is less than that value or x is more than that value. So none of these seem to make sense. So we're saying negative infinity to this and this to positive infinity. Bit of a bummer, but that's what we've got there. Function with the rule, this has an implied domain. So I'd be thinking negative 4 to 4, that one there, because of the fact that it looks like it's a semicircle, but we'll graph it just to be sure. So let's go to this next one, tab, I'll delete this, and I'll say the square root of 16 minus x squared. 16, oops, 6 doesn't work, 16 minus x squared. And there we have that. So it's going there. So we are at 4 and we go at the 4. So we've got a domain of negative 4 to 4. Last one along, circle in a diagram has this equation. So we have a center at negative 3 and 6. That means we're looking at x plus 3, y plus 6. So x plus 3, so it's B, C, or D. Oh, they're all minus 6. Oh well. It's supposed to be minus. So x plus 3, y minus 6. Now we're looking at our radius. Radius goes from negative 3 to 7. So we've got a radius of 4. So radius is 4. Remember, it's 2 to your radius squared r squared. So this one. So it's a radius 4 squared. So no, 16. That one there. So that's what we end up with. So that's what we have. We can graph it just to be sure. We can check that. We'll say make a new graph. That menu, let's change it to relation. And let's say we've got x plus 3. X plus 3 all squared plus we're y minus 6, y minus 6, all squared equals 16. So we've got there. Menu, analyze graph. X equals or graph 6. No, we're going to graph 6 to see what we have for 6. Oh, sorry. Graph y equals 6. Y equals 6. And we're going to check for some intersections. Negative 4 and 6. No, that's not right. We want negative 7 and 6. It's going to be 16. Menu, analyze graph, intersection, negative 7 and 6. Equals 1 and 6, 3 and 10. So check. So I'd be saying everything else is okay. If we want to check it, we can say x equals 3. Oops. X equals negative 3. So we'll check those all. Menu, analyze graph, intersection, that graph, first corner, second corner, negative 3 and 2. I'd be confident that. So that ends up being x plus 3, gets shifted across to the left, y minus 6, because it's gone up by 6, equals 16, so the radius of 4.